we need to have a bit of a conversation. I've been told that here at More Math, it's not necessarily rational how much I like numbers and math. So I thought we need to talk about this. Yes, we need to talk about rational numbers. I know you're excited. What in the world is a rational number? No, it's not a number that makes good decisions, although it could be. A rational number is any number that can be stated as A over B. There's a couple rules that go with it, though. A and B have to be integers, and B cannot equal 0. You know what that is, right? This little equal sign with a line through it, that means is not equal to. Makes sense. B is not equal to 0. Why can't B equal 0? Because we can't divide by 0, and we talked about that in another video. If you don't remember, go back and look in the divisibility rules. We can't divide by 0, so B cannot be 0. All right, but A and B are integers. We've heard that name before. Let's take a look at something. So, we talked about integers before. Do you remember what they are? Yep, that was the very first video we ever looked at together. That's exciting. It's been a while. We said that integers are the set of whole numbers. Ooh, let's start there. The set of whole numbers. I'm going to write down here, whole numbers. What is a whole number? A whole number is all the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 0. So I'm going to write down as an example 0, 1, 7, and 392 because those are all very fine whole numbers. So these are our whole numbers. So integers are the set of whole numbers. I'm putting a circle around it because it's a set. It's a group. And they're opposites. Oh, do we remember what opposites are? Yes, there was another video. Good job. We take the number, we keep the number, and change the sign. Doesn't matter what the sign is, we switch it. So if it's positive becomes negative, it's negative becomes positive. That's the opposite. So it's the set of whole numbers, which are all positive, and its opposites. So those are the, you got it, the negative numbers. So we're going to say integers. So we have whole numbers, and then we have integers. And these are the negative numbers. And I didn't leave myself a lot of room there for my drawing. Let's see if this is going to work. So in the integers, we're going to put -8 or -49. How about a -32? We can do all of those. So what is an integer? Here's a picture of an integer. It's all the whole numbers in this set, and we add it on to that. It also includes all the negative numbers. So is a whole number an integer? Yes, because it's inside the integer bubble, right? So is a -8 a whole number? No, because it's outside of the whole number bubble. Nice job. If you didn't do so, you should kind of pause the video a minute, grab a piece of paper and a pencil, and start drawing the picture. Your brain is going to love it so much more if you make the picture yourself and draw it and do all that. So, all right, so we've got the set of whole numbers and their opposites. Well, what's next? Well, the rational numbers are next. Let's use green. So the next big bubble is going to be our rational numbers. Yes, that's where the beginning joke came from. I tried. Don't judge me. So here's the rational numbers, and it's an even bigger bubble. Wow, just like that. So is a 1 rational? Yeah, because it's inside the rational bubble. Is a 1 an integer? Yes, it's inside the integer bubble. I think I said is 1 a whole number. I hope I said that right. Is 1 a whole number? Yeah, because it's inside the whole number bubble. Is 1 an integer? Sure is. It's inside the integer bubble. Is 1 rational? Yep, because it's also inside the rational bubble. But what's different? What's the difference between a rational and an integer? Rational number is where we start adding in all those fractions and decimals. But as you remember, we said, I'm going to write it here. I'm going to write a rational number. That's an L, in case you can't tell. And that means number is A over B. And they're both integers. That means a rational number is anything that can be written as a fraction. So for example, I could write 4/7. Yep, that's a rational number. I could write 1/10. That's not a fraction. You said a rational number is anything I can write as a fraction. It's not a fraction, but I could make it a fraction. This is the tenths place. This is 1/10. That's a rational number. Nice. So what is this called right here? This is called a Venn diagram, Venn diagram. It's a Venn diagram. And they're kind of cool. And we could add to this Venn diagram. We could put over here in its own little spot, we could put the irrational numbers, irrational, and they would be their own little thing. And then all of this would be the real numbers. And then outside of that, we have the complex, but we're not going in there. This is we're just talking about rational numbers today. So what I want to do is I just want to make sure we understand what a rational number is and that we can classify numbers. As in, if I gave you a number, can you tell me where it belongs here? Okay. So what if I said, what is the number? Start with 7. What is 7? And on your piece of paper, you would say, well, 7 is a whole number because look, it's right here in the whole number circle. But wait, it's not only in the whole number bubble, it's also inside the integer bubble. So number 7 is a whole number and an integer. Oh, you already got it. And because the integer bubble is inside the rational bubble, it is also a rational number. So every whole number is a whole number, it is an integer, and it is a rational. It has to be all of them. Okay, well, what about our number -8? How would we classify -8? We would say -8 is an integer. Can I say -8 is a whole number? Cannot, because it is negative, and that is not a whole number. Good job. You got this. So -8 is an integer and a rational number. Okay, so we can classify these. What about if I gave you the fraction 4/7? I already wrote it down there. Good. It is only a rational number. We're classifying it right there. Nice job. This is called classifying. For our rational numbers, we're saying if they're whole numbers, integers, or rationals. So we're going to practice writing some numbers as rational numbers. So let's say I gave you the number 10. Could I write the number 10 as a rational number? Because it's a rational number. How can I show you that it's a rational number? Well, we remember that a rational number, probably shouldn't have erased this part, huh? Means that it is A over B, where B cannot equal 0. So if the number 10, how would I write that? I could write this as 10 over 1. Why can I write that as 10 over 1? Because that's 10 wholes. The 1 just means there's one whole. This is a whole piece of pizza. Not a whole piece of pizza, a whole pizza pie, right? So if I have 10 pizzas, that means I have 10 whole pizzas. So if I have a number, a whole number, I can write it as a fraction just by putting it over 1. The 1 here is the ninja. We like to call the 1 a ninja. The ninja. This is the ninja 1. So that means under every whole number, whether you see it or not, there's a 1 hiding underneath it. So every whole number is a rational number because when I say the number 8, I'm not really talking about 8. I'm talking about 8 wholes, 8 over 1. So every time you see a whole number, I can make it a fraction by putting it over 1. It's a rational number. Well, what if I have a decimal? We talked about that a minute ago, that a decimal can be written as a fraction. So let's do that. We're going to use place value. So I know here's my decimal. The first value after the decimal is the tenths place, right? Yep. The second one is the 100ths place. And this last one here, the third one, is the 1000th place. I want to show you something kind of cool. You probably noticed this already, but in case you didn't, here's my decimal. I am one place after the decimal. That's the tenths place. How many zeros? 1. I'm going to go 2 places after the decimal. This is the 100ths place. How many zeros? 2. Does it work always? Think so. Let's try it again. We're going to go here. This is 1, 2, 3 places after the decimal. There's 1, 2, 3 zeros in 1000. This is the 1000th place. Just saying, it's kind of helpful to know how it works together, right? So what would this be? This is the number 15 over what place? The 1,000ths place. So it's going to be 15 over 1,000. Now, am I going to reduce that? I am going to reduce that. Am I going to reduce it right now? I guess so. 5 goes into both of them. How do we reduce? That's a later video. I'm not going to reduce it right now because that's not the point of this lesson. I'm going to get down a rabbit hole. We write this decimal as a fraction by putting it over its place. So this is 15 thousandths. It's 15 over 1,000. Let's try another one. What if I said 129 and I don't want to do thousands again, so I'm going to do 1,298. Let's make it a different one. All right, so we're going to do the same thing. I'm going to take this whole number. I'm going to write down 1, 2, 9, 8. I'm going to draw my little fraction bar. And then I'm going to say, how many zeros do I need underneath? What place am I putting it? Well, there's 1, 2, 3, 4. So I'm going to put 4 zeros. 1, 2, 3, 4. So it's 1,298 10,000ths. We are going to talk about reducing fractions, just not in this video. So that's how we can take a decimal and turn it into a fraction. We can see that it's a rational number because I can write it as A over B. And the last example I want to look at is what if I have a mixed number? Let's say I had the number 3.5, 3 and 1/2. Can I write that as a fraction? I mean, there's a fraction in there, so I think so, but it's not really a fraction yet. I want to make it an improper fraction. So how can I write 3.5 as an improper fraction? There's a lot of different ways you can look up. My favorite is just the big C, the big circle, right? I like to start here at 2, and I draw my little arrow like this. And so I say, I take the bottom number, the denominator. I multiply it by the whole number. So what is 2 times 3? That's 6. And then I take this 6 and I add the 1. So we can say 2. You know what? I think this is a good idea. 2 times 3 equals 6. 2 times the 3 equals 6. Add the 1. And what do we get? 6 plus 1 is 7. We get the 7. 7 what? 7 halves. We just keep the denominator. When we multiply by how many parts we break it into times the number of wholes that we have, that gives us the entire number of parts plus the leftovers. So we're using the same denominator, okay? Let's try one more. Sometimes mixed numbers are like, what? I don't get that. I don't know. Let's try another one. So what if we said, I don't know, how about 5 and 2/3? We're going to do the same thing. We're going to draw our little circle here to remind us what direction we're going. And we always start with multiplication and then we add. Huh, kind of like PEMDAS. Interesting. So we're going to multiply first. 3 times 5 is 15. 15 plus 2 is 17. So we're going to put 17 over what? We keep the denominator, the number on the bottom. So it's 17/3. And that's it. That's how we can turn a mixed number into a rational number. We can write it as A over B or as a fraction. And that's it. I just wanted to do a little review on rational numbers. I hope that it helped. Remember, rational numbers can be written as a fraction. A and B are integers. B cannot equal 0. That's all it is. Have a great day.